tea. The milkman, the paper boy, evening TV. Everywhere you look, there's a heart, a hand to hold on to. Everywhere you look, there's a face of somebody who needs you. Everywhere you look, when you're lost out there and you're all alone, the light is waiting to carry you home. Everywhere you look.
This lab was meant to test students' knowledge on one-dimensional kinematics and free-falling bodies. Using cinematic and scientific methods of observation, the parabolic paths of air rockets were recorded and analyzed to deduce the time of flight, the initial velocity of launch, the maximum height attained, and the final velocity before impact with the ground. We did this while neglecting air resistance. To maintain the safety of yourself and others in your lab room, beware of falling objects.
Oh! Somebody! Oh! He needs some milk!
Operate the rocket with extreme caution. Don't lean or stand over the rocket while pumping. And do not try and catch the rocket, even if Mr. Barlotta isn't looking. We hypothesize that if we will be able to find the initial velocity of the rocket, we will also be able to find the final velocity of the rocket, the time up, the total air time, and the max height reached.
To test this hypothesis, we conducted several trials with each level of valve and recorded the trials with Gilbert's iPhone. Each trial required a bike pump to produce pressure in the air rocket. The air rocket was mounted on a launch pad and contained a valve of varying threshold acting as the independent variable. A meter stick was used to measure the distance traveled by the rocket in a time frame, and to ensure accuracy, a fungus was required as a sacrifice to the physics gods. Apparently that last part was not needed. Oops. Forget I said anything. To calculate the initial velocity of the rocket, the distance in which the rocket traveled within the first frame was divided by the duration of the frame. To find the time spent by the rocket in the air, the final velocity of the rocket was added to the initial velocity of the rocket and subsequently divided by 9.8. The maximum height reached by the rocket is found by subtracting the initial velocity squared by the velocity of the rocket at its peak squared it and dividing by 2 and 9.8. This math was done for each trial, and the results were carefully organized and announced.
We found that for all trials, the initial velocity equaled the final velocity, and the time up equaled half of the total time.
Wow!
In conclusion, this lab showed students one-dimensional kinematics at work and provided good experience with announcing and organizing data and that.
Physics is a drag.